Okay, good. So everybody I can see that's voted so far, we've said is a right angle triangle. So perfect, right angle triangle. What two things should we be thinking about when we see a right angle triangle on a question paper? So type those into your Q&A if you like. What two things do you think you should be thinking about when we see a right angle triangle on a question? What two topics come to mind? Thank you very much. We got one answer in straight away. Okay, so we got the one answer. Well, we've got two topics we could possibly think of. What do we think they are? Good. Two people said the same thing. Good. We're getting some brilliant answers in here. So we've got quite a few people saying Pythagoras, SOHCAHTOA, trigonometry, Pythagoras. Good. Brilliant. Okay, so yes, those are the two things we want to be thinking about here. But we're looking for here a length, and we have two lengths. So what should we be using in this instance? So we've got two sides and we're looking for another side. So do we have any angles involved? We don't. So if we haven't got any angles involved, then we should be thinking about? Perfect, yes, Pythagoras. Okay, now this is the next one. Do you need to remember Pythagoras' theorem? Okay, bit of a mixed bag. Actually, these days it is on your formula sheet. Okay, so it's there on your formula sheet. So have a look on your formula sheet at the front. It is there for you, so you don't need to remember it. Okay, I know many of you already will, but it is on your formula sheet for your exam. Okay, so let's have a look at this question. So we have here A, B, and C. So first of all, what we're going to do is label our sides. So we're going to have A and B. It doesn't matter which way around we've got those two. C always has to be the longer side, the hypotenuse. Okay, so in this case, we're looking for B. Now, we know that A squared plus B squared equals C squared from our formula sheet. Always note that down for yourself. Okay, and then it's up to you whether you can rearrange now or after you've substituted in. So let's substitute in. We've got A is 6, so 6 squared plus, we don't know what B is, and we know that equals 14 squared. Okay, so calculator paper, remember, so we got 36 plus B squared equals 160, and then we can rearrange. So we've got B squared equals 160, well, we've got plus 36 here, so to go away from that, we take away the 36 from both sides, and we get, if I go over here, B squared equals 1 second. We're going to have to change that. My sincerest apologies. Let's get rid of that. I put the wrong number in there, which means that's going to be wrong as well. So we'll fix that now. There we go. So that should have been 196. So 196 take away 36, which gives me my 160. And then the opposite of squaring is the square root. So the square root of 160 gives us our B of 12.65. And we'll do some dots because that isn't our answer yet. And we want to round that to our 1 decimal place. So 12.7 centimeters. Okay, so remember, always note down your equation, your formula, substitute in, rearrange, and then work your way through on your calculator. Okay, question number 2. We got some simplifying to do. So we've got 2x times 5x times 3y. Now remember, when we multiply, we can multiply in any order we like. So the way we like to think about doing this, well, we're just going to do the numbers first. So 2 times 5 times 3. Okay, and then we're going to times by our x, times by our second x, and times by our y. So 2 times 5 times 3 gets us okay, so we've got some good 30, brilliant, thank you. Okay, and we've got x times x. What does x times x give us? X times x gives us, brilliant, x squared. That's not the greatest thing to be able to put on the screen down there. So x squared, and then the times by y. And just remember, we're a little bit lazy, so we don't want the time symbols. We're just going to put the letters next to each other. Okay, simplify 7a plus 5b minus 2a plus 8b. Now, you've probably seen your teachers in the past circle the like terms. And you probably thought to yourself, no, I don't need to do that. Okay, but remember in an exam, we just want to make sure we're getting everything right. Okay, so circle your like terms so that we know we got them. Circle the symbols in front of them so we know they go with them. Okay, and that way we can extract those out and get them right. So we got 7a minus 2a, because I've circled the minus in front of the 2. Then I've got plus 5b and plus 8b. We can join these together. So 7a take away 2a's gives us our 5a plus our 5b plus 8b gives us our 13b. And we've got our answer. We can't do any more because we haven't got any more like terms. Okay, so always just take your time in your exam, make sure you get them right by circling those to make sure you got the signs with the correct terms. And on to question 3, where Rob's going to take over from me.
There we go. Wonderful. Thank you very much. Right then, I'm going to go through a couple of questions with you now to do with circles. This first one we'll have a quick read through, and then I've got a little poll for you guys as well. So a circle is enclosed by a square as shown in the diagram. So as you can see, we've got a square on the outside and a circle that fits perfectly inside the square. And it says each side of the square measures 8 centimeters. So we'll just pop that on the left-hand side just there. Find the area of the shaded region, give your answer correct to 1 decimal place. Now, my first question to you guys this afternoon is similar to a poll that Rhys popped on earlier. Is the formula for the area of a circle on the formula sheet? Yes or no? If you're not sure, you can have a bit of an educated guess, can't you? Obviously, it's extremely important in this particular question that we understand that we are, first of all, dealing with area, that we are dealing with a circle. And it's important that you know, if you are given the formula for the area of a circle, that you can have a little flick towards the front of the formula booklet at the front of the exam and use that whenever you need it. Now, we've got a pretty split vote here, actually. The great news for you guys is that the formulas for circles, whether it's to do with area or circumference, they are on the formula sheet. Okay, let me just hide that poll. There we go. So yes, the formula for the area of a circle for this particular question is given to you on the formula sheet. So be careful, okay? If you do come across a question that involves area or circumference, as you can see there are circles, please nip back to the formula sheet, wherever it might be, on your desk and make sure you're using that, okay? A bit like the Pythagoras question that you went through a few moments ago. So in this case then, to work out the shaded area, we need to do 2 things, okay? We need to first of all work out the area of the square, so the area of the whole shape, if you like, and then we need to work out the area of the circle within it, and then work out essentially what to do with it. I've got a few really good answers in the Q&A actually as to what to do just here. I'll take one of those actually to work out the area of the square. Now remember, the area of the square is the same as the area of a rectangle. It's just base multiplied by height. Okay, so we're going to do 8 multiplied by 8 to give us 64 centimeters squared for the area of the square. Okay, and as mentioned before, the area of a circle is given to us on the formula sheet. Now, a question to you guys is, what is the radius of this circle? If you want to pop your answer into the Q&A pod for me, just give you a few seconds to work that one through. I've got a few correct final answers actually in the Q&A pod already, which is fantastic. It shows you're skipping ahead a bit quicker than me. What is the radius of the circle in this question? First of all, can you remember what the word radius means? That's not given to you. Well, it says R is the radius, obviously, on the formula sheet, but it doesn't actually tell you explicitly what is meant by the radius. But yeah, got a few great answers in there. The radius of a circle, remember, is the distance from the center of the circle to its circumference, which is on the outside. In this case, if the distance across the square is 8 centimeters, then the radius of this circle is going to be 4 centimeters. Okay, so to work out the area of this circle, we're going to do pi multiplied, just squeeze 4 just into there, and we're going to do pi multiplied by 4 squared. Now, I would recommend at this stage of the question leaving your answer as we say, in terms of pi. Now, what that means is it means you won't have to do any rounding until you get to your final answer. You can get penalised for over rounding if your answer becomes too inaccurate at the end. Okay, and as a few of you have mentioned already in the Q&A pod, to find the shaded area of this diagram, we're just going to do the big area of the square, so 64, and we're going to take away the area of the circle. Okay, and again, your calculator will do all this work for you. You can leave the pi symbol in there. It works through, and again, it does mention to 1 decimal place here. The calculator shows 13.734, and then, as is normal with pi, quite a complex decimal. To 1 decimal place, remember, you look for the number after the first decimal place, in this case, so the 3, and that will tell you whether to round the 7 up to an 8 or to leave it as it is. Okay, and in this case, of course, a 3 rounds down, leaving it as 13.7 centimeters squared. Okay. Again, as I said, a few of you managed to get that answer in the Q&A pod, which was amazing. Like I say, it's not an easy question, that one. I think it carries 3 marks. Again, just try and break your work down step by step. Make sure you're nice and clear with what you're doing. The examiner will very much appreciate working out that's nice and clear, and it's clear what you're doing step by step. Now, question number 4. Once again, we've got ourselves a question that involves sort of a circle. Obviously, in this case, it's what we call a fraction of a circle. The correct name for this shape is actually a sector of a circle. The poll for this question is, what fraction of a full circle is shown in the diagram? This is a really, really, really important first step for this question to understand how to work out ultimately the perimeter of this shape. Thank you very much for all the answers that are flying in. You're clearly on the ball this afternoon, ladies and gents. And you are all absolutely spot on. The answer is indeed 3/4. Okay, it's quite a common fraction, this one. Halves and 3/4 tend to be quite easy to spot. And what we're looking for in this question is the perimeter of the shape. Okay, now the perimeter, remember, is the distance all the way around the edge of the shape, whether that involves curved sides or straight edges as well. So ultimately, we want to work out this sort of big orange curved part. And then we also want to add on these 2 straight edges as well. Now, those 2 straight edges are going to be quite straightforward. We know that they're both 12 centimeters because they're both the radius of the circle. The tricky part for this question is going to be the outside of this shape. Now, we do have, as we mentioned a little bit earlier, a formula for the circumference of the circle. Okay, so the circumference of a circle is, there's two potential formulas. Pi times diameter tends to be the most often used for circumference. Okay, now pi times diameter, what that will do is it will work out the total circumference of a circle depending on its size. Okay, so that will involve this curved part here as well that I don't want. That's why it's really important that we understand that this diagram here represents only 3/4 of a circle, not a full circle. So to work out the distance around the curved part of this shape, what we want to do is we want to find 3/4 of the circumference. Now, to find 3/4 of something, we can either divide by the bottom and times by the top. If we're doing it without a calculator, that tends to be the best way. Or if we're trying to find 3/4 of a number with a calculator, we can just multiply that thing by 3/4. So in this case, to work out the circumference of this circle, I need to do 3/4 multiplied by pi times by the diameter. Now, once again, I'm going to ask in the Q&A pod, what is the diameter of this circle? Or should I say, what is the diameter of this sector, as it's not quite a full circle? Give you 5 seconds to get your answer in the Q&A pod. What is the diameter of this sector? Wonderful stuff. Thank you very much for all your answers. The correct answer, you are all spot on, is 24 meters. Remember, the diameter is the distance all the way across the shape. Always double the radius. Okay, so this calculation here, 3/4 multiplied by pi times diameter, that is going to work out for me the curved part, if you like, of the perimeter of this shape, this section just here. Again, I'm going to leave that in terms of pi until my final step. 3/4 multiplied by pi multiplied by 24 comes out as 18 pi. And then, as I mentioned right at the start of this question, all I'm going to do then is add on the 2 straight edges. Okay, you've got a 12 meter line and another 12 meter line, hence a total of 24 meters added on as well. Okay, now the question may, even though it's a calculator paper, it may still ask for the answer in terms of pi. If it does, then this is your answer. Okay, there's nothing you can do here. You can't combine these two terms because one is in terms of pi and one isn't. But with it being a calculator paper, you're probably best off popping that in. And unless the question says otherwise, I would always recommend 1 decimal place for your final answers. And in this particular question, that would come out as 80.5. And because we're dealing with a perimeter, it's a distance, so it's measured in things like centimeters, meters, or millimeters. In this case, of course, it's measured in meters. Okay, so remember, any question that involves area or circumference of circles, look at the formula sheet. There's going to be some help on there for you. But I will now pass back over to Rhys for questions 5 and 6. Oh, here we go.
Thank you very much, Rob. Okay, so moving on to question 5, so we've got a table. Ben is measuring the height in centimeters of students in his class. Okay, we've got some information there, and then it says to estimate the mean height. Give your answer to correctly to 1 decimal place. Okay, so we can see here straight away we've got a little bit of a problem because we should, hopefully loads of us remember that to find the mean, we've got to add them all up and divide by how many there are. Perfect. So we've got some people in there already already telling me, well, this is a bit difficult, so I haven't got a number here to multiply my frequency by. But some people in there are telling me that we need to find our midpoint. Okay, so we can add an extra column in our table here with our midpoint. Okay, sometimes in an exam it'll give you this extra bit of the table, other times it won't. This one didn't, so you need to remember to put the midpoint in yourself. So we're going to find the midpoint of 140, 150. Okay, which we have as in the Q&A, then what do we think that midpoint is? And then we'll talk about how we find it if you're not sure. Perfect, thank you. We've got a couple of 145s coming in together. Okay, now hopefully this one isn't one that's too tough, okay? Because halfway between 60, 160, 170, 165. But if it is a little bit more difficult, remember what we need to do is add the two that we have, and then we divide by 2. Okay, so we find in the middle of those two numbers. Okay, so that's how we do it if it's not so obvious. Add the two numbers, divide by 2, find the mean of those two numbers, the middle of those two numbers. Okay, so now we've got our frequency, our midpoint, and then we need to multiply. Okay, so we're going to multiply our frequency by our midpoint to get our answers over here. Okay, so we've got 1,015. Oh, they're coming in thick and fast in the Q&A. Let's see if I can keep up. 1,550. And we've got 2,475. Okay, so remember, mean is add everything together. So this is my big numbers. This is going to give me my total. Okay, so we add those together, we get 5,040. And we need to divide by how many we have. And that means the total frequency. So we need our total in here as well. So our total frequency is 32. So we've got 5,040 divided by 32, which gives me 157.5. So 5,040 divided by 32, 1,057.5. Okay, there's my answer. Does that seem sensible looking at our table? Do we need some units with there? What units do we have? Centimeters, good. Okay, so we need our centimeters in there. Okay, and does it seem sensible? Does this fit in our table somewhere? Okay, and that's always an important thing to think about when you're in an exam. If my answer was 276, for example, well, it's out of my table, so I know I've done something wrong. Okay, but this is somewhere in the table, so at least I know I'm possibly right. Okay, so we can leave that as there. Okay, next question. We have our graph. So here is a graph of y equals x squared minus 2x minus 3. We need to write down the turning point of the graph. So turning point, well, quite self-explanatory in the word. It's where the graph turns. If we think about our graph coming down and it going up, that's where it turns. Okay, so we want to look for the point where it turns, which is this point down here. And we've already got plenty of answers coming in. If you're not sure about these, fill them in. So that's a gap of 2. Well, we can put the middle of 1, 3, 5, and the same down here, -1, -2, -3, and -4. Take the time to fill those in. You might need them later anyway. So our point is 1, -4. Remember, along the corridor first, and then up or down the stairs. 1, -4. We then want to find the roots of the equation where y equals 0. So we need to think, where is y 0 on this graph? And we need to remember that y is 0 across there. So essentially, when it says looking for the roots and y equals 0, we're looking for where my graph crosses the x-axis. Okay, and we've already got some of those coming in lovely there already, so well done. Okay. So we've got 0 to -1, and we've got 0 and 3. So we can say that x equals -1 or x equals 3. Okay, the 2 points where those cross. Thank you for those answers that come in there. Well done. Okay, we are a little bit short on time. Let's see if Rob's got time for one more question. Oh no, we finish at 5, don't we? Let's keep going. Question number 7 for Rob.
Thank you, Rhys. Right then, so yeah, question 7. In many ways, a nice question, this one, in the sense that it is only worth 1 mark, as you can see in the bottom right-hand corner. It's actually a really nice question, this one. However, it does rely on you knowing the formula that links density, which is what this question is asking for, mass and volume. Okay. Now, there are formulas that we call them compound measures. Okay. Speed, distance, and time are 3 measurements that sort of come together in a way, density, mass, and volume, and you have pressure, force, and area as well. Now, those formulas aren't on the formula sheet. So your poll for this question is, what indeed is the formula for density? Is it mass times volume, mass divided by volume, or volume divided by mass? Like I said, this question is extremely straightforward if you have a calculator, but only if you put the right numbers in the right formula. Okay, the calculator unfortunately doesn't know if you're using the right formula or not. Thank you very much once again for all the votes flying in. We've got a slight favourite with density equals mass divided by volume, which is indeed the correct formula. Okay, density equals mass divided by volume. A very, very important formula. Density is a really, really common topic on the calculator papers. So if it doesn't come up tomorrow, there's a very strong chance we'll be seeing it in paper 3. Now, the reason I said this was quite a nice question was because really from there, you're told the mass, it's 720 grams. You are told the volume, it's 40 centimeters cubed. And it's a calculator paper. So you pick up your calculator, you divide those 2 numbers, and you end up with an answer of 18 grams per centimeter cubed. So lots of correct answers again in the Q&A pod. The only thing to look out for on questions like this is just be careful of your units. The question measures the mass in grams and the volume in centimeters cubed, and that's exactly the units of density that we see in the bottom right corner here. There are times where you may have to convert from grams into kilograms or from centimeters cubed into meters cubed, depending on the question. But generally speaking, if it's a 1 mark question, they're not going to worry too much about getting you to convert different things. That 1 mark really there is for remembering the formula. Okay, so once you've done that, you plug your numbers in and away you go. Okay, so quite a nice little question, that one, if you remember the formula. The question that isn't quite as nice is this one just here. Now, I was going to ask, similar to Rhys a little bit earlier, what sort of triangle are we dealing with? Is it Pythagoras? Is it trigonometry? But if you're very lucky tomorrow or in paper 3, they will explicitly tell you to use trigonometry, in this case, to work out the size of angle W. Now, as we mentioned earlier, the formula for Pythagoras is on the formula sheet. There is also the formulas for trigonometry on the formula sheet as well. Now, it uses the same letters that are used in Pythagoras' theorem, so the A and the B for the two shorter lengths, and the C for the longest side, which is known as the hypotenuse, of course. And you can see here down in the bottom right-hand corner, we have a formula for sine A, we have a formula for cos A, and we have a formula for tan A. It's just a case of making sure you label your triangle correctly. So you can see here in this bottom diagram on the formula sheet, they use the letter capital A to represent the angle that in the question. The length lowercase a is always opposite to the angle. So in this case, it's really important that we label A as the side opposite to the angle. C, as you can see from the diagram, is the hypotenuse, which is opposite to the right angle. So C is going to be this length here. And then B is what we would call in sort of the old way of doing it, the adjacent side, which we can label as the 6.7. Now, I know some of your teachers may have taught you the hypotenuse, the adjacent, and the opposite, which is the way that I tend to teach it as well. But if you do want to use the formula sheet, you sort of have to convert yourself over, if you like, to using A, B, and C. My poll question for this one, ladies and gents, is, should I now use sine, cos, or tan to work out my missing angle? Bearing in mind, you know, how I've labelled the sides of this triangle, which one of the three trigonometry functions is going to be used here? Again, we've got a bit of a split vote coming in. So yeah, just to answer one of the questions in the Q&A pod, if you are lucky, it will just say use trigonometry. It doesn't always do that, though, as you may have found in some mock exams. So you can't always rely on the question saying, you know, use Pythagoras or use trigonometry. But if it does, then it's one less thing to worry about, I guess, isn't it? Right, thank you very much for voting. The majority vote went for cos, and that is indeed correct. Let me just pop that pod to one side. So yeah, in this case, ladies and gents, we have been given C and B. So when you look at the formulas down at the bottom here, you're looking for the formula that involves both side B and side C. So in this case, we are indeed going to use cos. So cos of capital A, remember capital A is the angle in the question, which is what we're trying to calculate. So we're going to leave that as the W. We're going to convert that over to the letter that they've used in the question. And then I can just replace the B in the formula by my length B, which is 6.7. And I can replace the C in the formula by my length C, which is 8.3. Now, from here, this is where some students get a little bit confused, okay, because it's a case of, well, how do I get W? Okay, now what you can't do is divide both sides by cos. Now, normally when you have sort of two things next to each other in algebra, it tends to mean they've been multiplied together. But yeah, someone's popped the solution actually in the Q&A pod. We actually use what we call the inverse trigonometry functions, which look a little bit like this. Okay, we sometimes call it cos to the -1, and that can be accessed on your calculator by pressing Shift in the top left-hand corner, and then pressing either sin, cos, or tan. Just a quick question in the Q&A pod here. How do you know if we use sine, cos, or tan? It's all to do with the lengths that you are given in the question. Okay, so you can see at the bottom here, the reason we used cos was because I was given in the question, if I just go over to my highlighter, I was given B and C, and cos is the formula that uses B and C. If I was given, for example, A and C, then I would use sine, because that's the formula that uses A and C. If I was given A and B, I would use tan, because that's the formula that uses A and B. So it's all to do with which side you're given in the question. Anyway, back to solving the problem. To find W here, we use the inverse cos function. It will then open up a bracket for you on your calculator screen. It's just a case then of popping that fraction into the brackets and pressing equals. Okay. Little hint for you is that when you're trying to find a missing angle, that is when you use the inverse. Okay. Inverse is only used in trigonometry when you're trying to find a missing angle. If you're trying to find a missing length, you will not use the inverse. Put that into your calculator then, ladies and gents. We've got 36.2 degrees for our missing angle. Again, I've rounded that to one decimal place, unless the question says otherwise. So again, anything to do with trigonometry, if you're unsure, check the formula sheet. Okay, I know some of you have been taught it without using that formula, and that's fine. But if you need the formula sheet, remember it's there. Wonderful. Right, I'll pass back over to Rhys. We've still got a little bit of time, haven't we, to crack through the next couple of questions. So I will see you all again momentarily, I'm sure.
Thank you, Rob. Okay, so yeah, let's move on to the next one. Hopefully quite a short one. So the scatter graphs show the scores of 16 students on their biology and physics tests. Okay, so what kind of correlation can we see? So we've got a poll for this. What do we think we can see? What kind of correlation can we see looking at that there? Okay, good. Okay, so lots of people agreeing, one or two not so much. Okay, so we can see here we've kind of got a general upwards trend. Okay, so we've got a general upwards trend, which would mean that that is positive correlation. Okay, so positive correlation. So we can write down positive correlation to get yourself your mark. Okay, so positive correlation. Now, we then say another student scores 52 marks in the biology test. Estimate, and it means estimate because it's not going to be a perfect answer because these can change, the physics score of the student. Okay, so if you've missed your you've taken your biology test but missed your physics tests, your teacher can use everybody else's results to have a bit of a guess at what you might have got. Okay, so what do we need to draw first of all to help us be able to calculate that? What do we need to draw on this diagram? Thank you. We got 1 or 2 correct answers in there. So good. Yeah, we need to draw ourselves a line of best fit. Okay, so to draw ourselves a line of best fit. Now they're going to be different for different people. Okay, I'm going to draw myself. Oh, that's a square. Let's get a line up rather than the square or a rectangle. Okay, so I'm going to draw myself my line of best fit. Okay, and I'm going to plot mine about there. Okay, now some people might say that it would be better if it was down here a little bit or up there, okay, but it doesn't matter too much as long as it's more or less where the examiner expected to be. They'll have a variation of where they're allowed it to be. Okay, so there's my line of best fit. I'm then going to say we've got a mark of 52 in biology, so I'm going to look for biology and I'm going to gather down here and I'm going to look for where 52 is. Well, I know that I've got there, so in the middle I'm going to have 50, which means I've got 1, 2, 3, 4, 5 lines making up 10, so that means they're going to go up in twos. So that little line, I'm going to go up. Okay, it's quite difficult to do on here, but I'm sure you've seen your teachers do it. We're going to do some dotted lines to go up until we meet our line and we hit it there, and then I'm going to go across and get to here. Okay, and this is the same scale. Okay, 20 gaps, so that's going to be 62. So we'll say that an estimate is 62 marks. Okay, now remember what I said. It could be that you've drawn your line of best fit over here, so that's going to change that score slightly. Okay, as long as you draw your line of best fit and you read correctly from your line of best fit, you're going to get the marks. And the examiners will have, again, a range of marks. In this one, it might be something like between 58 to 66, something like that. Okay, so you'll get yourself your marks if you're within that range. So make sure you draw that line of best fit and then use these lines to show that you're using that line of best fit to get your answer. Okay. Last question from me, and potentially the last one. See how we go on, see how much time we've left at the end of this one. So the rectangle and the triangle have the same area. So remember in your exams, let's underline. We've got rectangle and triangle, and it says they have the same area. Work out the length of the rectangle. So this is what we're looking for, the length of the rectangle. First of all, how do we find the area of a triangle? Which formula is correct for the area of the triangle? Area of the triangle. Remember, I covered that rectangle up because I don't want you to be thinking about that rectangle. How do I find the area of a triangle? Okay, good. Most of us have got that correct, so well done. The area of a triangle. Okay, we're going to do half times the base times the height. Okay, so half the base times the height for our triangle. Okay, so we've always got to remember with these questions, we just got to think about what we're going to do. Okay, if we've got no idea how we're going to find the length, we can still find the area of the triangle just to get ourselves a mark. Okay, so if you know nothing else what to do and you've remembered how to find the area of the triangle, make sure you do that to get yourself a mark. So we've got half times the base, which is 12, and times by 16, which is our height. So the area of my triangle is 96 centimeters squared. Okay, how do we find the area of a rectangle? What's the formula for the area of a rectangle? Length times width, base times height. Yep, we're getting all of those in there. Good. We have got length in here. Okay, I normally say base times height, to be honest, but because we've got the word length, I'm going to say that the area is length times by my height. Okay, so in this case, it's going to be my length, which I don't know, times by 7.5. But do we know the area? This is where we're going to go back up here. And we were told that they are the same area. We've already calculated the area of the triangle, so I now know my area of my rectangle is 96. Okay, so we can take that down here. 96 equals length times 7.5. Okay, so we've got ourselves a little equation. How are we going to get rid of times by 7.5? What is the opposite of times in by 7.5? So what's the opposite of times in or multiplying? Good. I'm getting used to these polls. Well done. We're nice and quick on them. Well done. Yep, we need to divide. So my length is going to be my 96 divided by 7.5. And it is a calculated question. So we're going to divide those in. And I've already seen we've had one or two correct answers. Some people really early on, so really well done for getting those so quickly, of 12.8. Okay, so we've got our answer of 12.8. So remember when you see these questions, it says to find the area of the thing you know. Think about how you would find the area of the other thing, and then it will say they're the same area, or it might have something else like area is 10 centimeters squared more, something like that, and you can use that information to help you find your missing value. Okay, I think we've got about 5 minutes left, so we'll just finish up with having a quick look at our formula sheet. Now, I know myself and Rob have mentioned it a few times, okay, but just be aware, remember that it is there. Okay, so that is your formula sheet for your foundation. Different things on them. We've got area of a trapezium, so remember it's there. Volume of a prism. Radius and d of the diameter is there because we've got the circumference of a circle and the area of a circle, which Rob mentioned both of those earlier. We've got Pythagoras' theorem, which I mentioned, then trigonometry, which Rob mentioned. We've got compound interest, and we've got some probability, which we haven't covered today, but remember they are there to help you out, okay? So refer to it all the time, keep on having a look at it. If you are taking higher, then you've got a few additional things on there as well. Okay, so you've got the same bit at the top here. You've got the same in the middle here, plus you've got your sine rule, cosine rule, and the area of any triangle. Your compound interest is the same, and you've got an additional probability one there compared to that one was only got the one. And you've also got your quadratic formula up there as well. So use that, make sure you're aware of what's there. Okay, make sure you're using them all. Any questions that we've got before we go, pop them in the Q&A and let's see if we can answer some of those. Anything anybody wants to ask, any topics at all that we can try and answer nice and quickly before we go. What about simple? Simple interest isn't on your formula sheet, but you need to be able to calculate it. Okay. It doesn't. So somebody said, does the formula sheet mean that everything will show up in the exam paper? It doesn't mean that. They're on all your exam papers, okay? It's always the same formula sheet. So there could be some things on there, they could not. So some things might not be used at all. Okay, brilliant. Well, I think firstly, Rob and myself would like to thank you for all the questions and answers you've put in. Getting involved has been really useful, and when people respond to us, so brilliant. Thank you very much for that.
What I would say is, if you are wanting to go over any specific topics between now and the exam, websites such as Maths Genie, they're great for finding specific topics. They've got videos, they've got exam questions. Obviously, we can't go through every single topic with you now. We've only got 2 minutes left. Hopefully, we've covered some useful ones for you. But yeah, websites like Corbett Maths, Maths Genie, they're great for finding specific topics. And there's a few videos on there, a few exam questions that you can use for any last-minute revision. So yeah.
And last thing, I suppose, is good luck tomorrow. And good luck next week as well on paper 3 when that comes around. But concentrate on tomorrow. Good luck tomorrow. Remember, nice and calm, highlight things, take your time, make sure your answers make sense. But thank you very much for joining us. Okay, bye guys.
Bye-bye. Thank you very much.
Thank you. Bye.